Alright, we got one of them up. We're gonna move to the other side.
So this is a reservoir. There's a lake on the other side of that dirt embankment. I'm standing on top of a standpipe for hydraulics. And this is the first time I'm looking over. It is super cool. So what you're seeing is a second pipe inside the first pipe, and water is fed by a gravity basin, which is a little bit higher in elevation. So water can flow down the pipe system from the higher basin into here. And because the other basin is a little bit higher in elevation, water is pushed up through this pipe, which daylights at a lower elevation. So the function of the standpipe is not actually what you're seeing it do here. This is just it coming through in gravity, spilling out over, being exposed to atmosphere, which is a zero pressure, and then it is going on into the river, flowing in gravity into the lake. So the purpose of it is actually a whole different component. So think of it like a valve. A valve in the open position is working. There's water going through it, but it is not actually doing anything to the system. It might be having a little bit of friction loss, so it does affect the hydraulics, but essentially it's just sitting there open. Same with the standpipe. Right now it's being fed water's gravity flowing through the standpipe and then into the reservoir, and it's just kind of sitting there. Its purpose is so that when we turn on the pumps, there's enough water that can be sitting in there that will push back against the pumps to make the pumps run better. So it's actually really cool in the way that it's designed. The standpipe that I'm standing on is the same height as the reservoir top, so that you would never have an elevation that is higher than what's in the reservoir. So it's kind of cool, right? You can just watch water. It looks like a fountain water feature you'd see at a hotel or something. You just watch the water flow down. It's very relaxing up here. You can just feel the wind rush by under my hard hat, and I can see out on the whole site, so it's quite beautiful. Okay, so now I am going over the edge to see what it looks like when there are two pumps running. So for pumps, if you have pumps in series, so they're just strung together, then it will increase the amount of pressure which comes through the system. But here the pumps are connected in parallel, so the pressure that is coming out is the same with just one pump running, but it now has twice as much flow. So that's what you're seeing here. So we've come up today to see how the pumps react when we start turning on multiple pumps. These pumps all have variable frequency drives on them, so we can actually key them down, make them go faster or slower. And so right now it's two pumps running at 100% speed. And we've just kicked on a third pump. So you're seeing it kind of go down and fill in the airspace within the piping system underneath the standpipe. And in a second here, you'll see what it looks like with all three pumps running. And now at this site, this is the first time we've ever run all 3 pumps. So I've got a front row seat advantage to seeing these pumps run, which is really kind of neat. And there we go. It's a bit aggressive looking, but that's just because there's air pockets in the piping system, probably near the top part of the pipe that didn't fill in with water just now. And so now that we've turned on the pumps, you're seeing it push all those air pockets out. So this is the first time we've run the pump, so this is the first time where, you know, this will happen. And it is rumbling, and it just feels incredible on top watching all this water. I don't think you get a really good sense for how much water is here. It's just spewing out, the whole thing is shaking, and yeah, it is quite incredible.
Have we tested it out with 4 pumps on before?
No. 2.
Maybe we want to get down.
I'm a little fake. This is the first time we've run 3.
Who's the structural engineer? Do we trust him?
I asked him to be here, but he says no way. It's Howie.
Okay, so that was the buzzing that you heard, which is the motor turning on. The pumps are located not too far away from where we're standing, so we can hear it. So, like before, this is the first time we're seeing this system run with 4 pumps in parallel pushing out flow. Now, this pump station, there's 5 total, 4 big ones and a littler one, and together I believe they do something like 700 cubic feet per second CFS. So it's quite a bit of water. We'll probably never use it more than about 550 CFS, but they were designed so that if we need to cool down the lake really fast, we can flip it all going the other direction at 700 CFS. So just like before, you're seeing all this air coming out. The vents are venting air and water. This air pocket is gushing up. And I'm standing up on top here with our hydraulics engineer who did all the hydraulic modeling. So it's really neat to listen to his perspective. And he mentions that he's got the vents pointed down, and that was something that he had talked to the mechanical engineer about designing, because he knew that this much water was going to be coming out of the vents, and if they weren't pointed down, we would be soaking wet from standing up here. So I'm so nervous about dropping my phone just because there's so much water rumbling and moving around. And I'm holding on to the rail and holding on to my phone and just watching it all happen. So that's why this shot is a little, it's not the greatest, but.
Now when Larry laid them, said Larry point them down.
Yeah.
He's like, huh? You think we'll beat that? I go, yeah.
Hopefully you get a sense for just how much water there is and how neat it is to stand up here and watch all of this happening.
Yeah, let's go.